Hello everyone. This is another video on quantum mechanics previous year questions from TIFR. Right. So let's try to solve more questions. We solved four questions yesterday. So this will be our question number five. Right. Question number five says if sigma I represents because I is equal to x y z, Pauli spin Pauli spin operator corresponding to spin half particle corresponding to spin half particle and I cap is the unit operator unit operator, then Sx Sy Szq is given by option A h cut by 2 whole cube I h cut by 2 whole 5 minus I h cut by 2 whole 5 0. Okay, please try this question. If sigma I represents Pauli spin operator corresponding to spin half particles and I is the unit operator, then Sx Sy Q. Okay, so let's start solving this question. Sx Sy Szq. How to solve it? Sx Sy Szq. Okay, so Sx we know if we can rewrite the relation between Sx and Pauli matrix h cut by 2 sigma x, Sy is equal to h cut by 2 sigma y, Sz is equal to h cut by 2 sigma z, correct? We'll just put them simply here. So h cut by 2 sigma x, h cut by 2 sigma y, h cut by 2 sigma z whole cube, right? Yeah. So this will be giving me h cut square by 4 sigma x sigma y. Then from here h cut cube by 8 to sigma z cube. Okay. Sigma z cube. Okay. Sigma z cube I can write. Okay. This becomes h cut 5 by 32 sigma x sigma y. Okay. H cut cube I can write h. Sorry. Sigma h z cube I can write sigma z square into sigma z, right? And the square of any Pauli matrix is 1 or your unit operator, right? I, correct? So this one becomes I or 1, like the value is. So h cut 5 by 32 sigma x sigma y sigma z. Okay. So now we know sigma y sigma z is what? Sigma y sigma z is I sigma x. Or you can take another other one, sigma x sigma y is I sigma z. Okay. So this becomes h cut 5 by 32 sigma x into I sigma x. Okay, sigma x again, sigma x square, that is unit operator. So the answer becomes I h cut 5 by 32. Okay, so this would be your answer with a I at the end. Okay, sigma x is I. Okay, the answer is I h cut 5 by 32. Will that be correct? Yeah. So answer is which one? Option B. Next question right now. Question number 6. The rotational part the rotational part of the Hamiltonian of a diatomic molecule of a diatomic molecule is h cut is equal to 1 by 2I lx square lx ly square h cut lz by I. Okay, where I is not a unit of it. I is the moment of inertia. I is the moment of inertia. I is the moment of inertia. So the degeneracy of the energy level of energy E is equal to 3 h cut square by 2I for L is equal to 1 is. What is the degeneracy? Option A 1, option B is 3, option C is 4, Option D is 5. Rotational part of the Hamiltonian of a diametric molecule is given. Okay. I is the moment of inertia. The degeneracy of the energy level of energy E is asked. For L is equal to 1. Okay. This is a very good question. Okay. So I'll try to solve it. Hamiltonian is how much is given? 1 by 2I Lx square plus Ly square, okay, plus h cut Lz by I, right, is equal to 1 by 2I L square minus Lz square plus h cut Lz by I, correct? This is the Hamiltonian. Because we can write Lx square, we know L square is equal to what? So this is L square. L square is equal to Lx square, so Ly square plus Lz square, right? So I can write L square minus Lz square is equal to L square plus Ly square, correct? I just put that here. So this becomes uh, okay, expectation value. So energy is the expectation value of Hamilton. So 1 by 2I expectation value of L square minus expectation value of Lz square, okay, plus h cut expectation value of Lz hmm, by I. Yeah. So expectation value of L square is L into L plus 1 h cut square, right? So h cut square goes out. So h L into L plus 1. This is your mh cut, mh cut, but a square is also m square plus h cut m only by I, or ml, you can write ml. Yeah, alright. So for L is equal to 1, okay, it's asked in a question. For L is equal to 1, we have to find, right? L is equal to 1. Okay, for L is equal to 1, ml values will be 12 plus 1 values, that 3 values, minus 1, 0, 1. So let's see. So for L is equal to 1, energy values will be first energy, suppose for E is equal to 1, L is equal to 1. So h cut by 2I, this becomes 2 minus 1 plus h cut by I. So this gives me 1, so h cut square by 2I plus h cut by I, correct? E suppose ml is equal to 0, cut by 2I, 2 minus 0, and this becomes 0. So this gives me h cut square by I. Suppose for minus 1, so E minus 1, h cut square by 2I, and this gives me 2 minus 1 minus h cut by I, right? So h cut square by 2I minus h cut by I. So this is your what? So these are the energies, and if you see, none of the energy are same. All are different here, right? This is plus, this is, so all are different. That means the energy states are non-degenerate, right? There is no degeneracy, non-degenerate. So there is no degeneracy. So no degeneracy means degeneracy is one. So value is one. Answer is one. Okay, next question right now. Let's take the next question. The question number 7. Okay, question number 7. Uh, an electron is in the state with spin wave function, spin wave function phi s is equal to root 3 by 2, 1 by 2 is in SZ representation. What is the probability of what is the probability of finding what is the probability of finding the Z component? What is the probability of finding the Z component of its spin along the Z direction? Okay, an electron is in the state with spin wave function phi s is equal to root 3 by 2, 1 by 2 is an SZ representation. What is the probability of finding the Z component of its spin along the Z direction? So, if I try this question, so let's first phi s is equal to 3 by 2, 1 by 2. So, you can write this as any wave function can be written as a linear combination, okay, of different eigenstates. So C1 1 0 plus C2, because this is a C1 spin, okay, electron, okay, spin a particle. C1 1 0, C2 0 1. Okay, so this is along plus z direction, this is along minus z direction, right? Yeah. So from here we can, if you see, if I write this down, if you see C1 plus 0, so C1 plus 0 is root 3 by 2, so C1 is root 3 by 2 and C2 is a 1 by 2, correct? Yeah. So the probability of finding z component of its spin along plus z direction and the positive z direction, so positive in this one, so the square of the coefficient will be the probability of positive z direction, right? So square of the coefficient, the C1 square, that is 3. Yeah. Suppose it was asked minus z direction. So square of the coefficient of the minus z, that will be 1 by 4. Okay. See, if you see, the total probability is now. Alright? Yeah. Next question right now. It's question number 6, right? Answer. Question number 8. An energy eigenstate of the hydrogen atom has has the wave function psi nlm r theta phi is equal to 1 by 81 root pi 1 by a naught to the power 3 by 2 sin theta cos theta exponential minus r by 3 a naught plus I phi. Okay, where a naught is the bore radius, yeah, the principal azimuthal azimuthal and magnetic quantum numbers, magnetic quantum numbers corresponding to this wave function r. Okay. Option A, n is equal to 3, l is equal to 2, m is equal to 1. Option B, n is equal to 2, l is equal to 1, m is equal to 1. Option C, n is equal to 3, l is equal to 2, m is equal to minus 1. Option D, n is equal to 2, l is equal to 1, m is equal to plus or minus 1. This came in TIFR 2013. Okay, so this is the wave function given. We have to find the quantum numbers that are used in the wave function. Okay, so let's write the wave function first again. So psi nlm r theta phi is equal to 1 by 81 root pi, yeah, 1 by a naught 3 by 2 sin theta cos theta exponential r by 3 a naught plus I phi. So this type of questions need to be very easy, not hard. See, first of all, uh, how to check it, how to know. See, you will first check the exponential term. So suppose, so the exponential term should actually be I e to the power I ml phi. Okay, but here if you see it e to the power minus I phi. Okay, only see that phi term. So we will equate it. So from here if you see what is ml, so from here we can see ml is minus 1. Got it? So m value we got. Okay. How to get the L value? L value is, we get L value by seeing how, what is the power of the theta terms. How many theta terms are there? Sin theta is there, cos theta. So how many? What is the total power? 2. This is power 1, power 1, 2. So if the power is 2, so L value is 2. Simple. Very simple. Okay, you can see right here, power of theta terms. M, how will you get M? By equating e to the power I m phi with the e to the power I phi term, whatever. Okay, I phi term. Right. Now n is what? N is simply the, this one, the other exponential term here. One is we have done, another is e to the power minus r to the power 3 r by 3 a naught, e to the minus r by 3 a naught. So it's actually this, actually it is r by n a naught. Okay, so simply you can see n is equal to 3. So this is the way you can get the values of n l m. Okay, so answer is n is equal to 3, l is equal to 2, m is equal to minus 1. Let's see which option matches this description. This one. Option C is the correct answer. Okay. Do exactly another question just for practice. Question number 9. Exactly similar type of question. Let's do. An atomic state of atomic state of hydrogen is represented by the following wave function: psi r theta phi 1 by 8 root pi z by a naught to the power 5 by 2 r sin theta e to the power minus r by 2 a naught to the power minus I phi. The quantum number of the states are n is equal to 2, m is equal to, l is equal to 1, m is equal to 1, n is equal to 2, l is equal to 0, m is equal to 0. Option C, n is equal to 2, l is equal to 1, m is equal to minus 1. Option D, n is equal to 2, l is equal to 1, m is equal to 0. So this is the question again. Let's try exact similar type of question that we have done in the previous one. Here I have even expanded this term. We can, okay, let me do one thing. If we get a similar exponential minus r by 2a naught plus I phi, we can write like that also. So from that you can try. Okay. So again, here what is the situation? Hmm? So here, okay, first m, right? M means e to the power I, e to the power item. We have to like compare. So e to the minus I phi here again. So minus I phi is equal to e to the power what? E to the power I m phi, correct? Isn't it? So e to the power I m phi. So if from here we got m is equal to minus 1. Okay. So this is the option C. Let's check the other ones. Here L only theta terms, right? How many theta terms are there? Only single theta term. So L is equal to 1. N. Now this gives us the n. So n is 2. Okay. 2, 1, minus 1. Option C. See how easy it is. Okay. Next is the next question. Basic question. The expectation value of x coordinate, expectation value of x coordinate in the ground state of hydrogen atom, in the ground state of hydrogen atom is expectation value of x coordinate in the ground state of hydrogen atom is option A is 0, option B A naught, option C 3 A naught by 2, option D A naught by 2. Okay. The expectation value of x coordinate in the ground state of hydrogen atom is 0, A naught, 3 A naught by 2, A naught by 2. Try. So let's try this. Expectation value x coordinate. So first of all, what is the wave function for hydrogen atom? Wave function of ground state of hydrogen atom. Ground state of hydrogen atom. What is it? Psi 1s is equal to 1 by pi a naught q root over, right, e to the power minus r by a naught. Yeah. So in spherical polar coordinates, we have to write the x coordinate. So x is, we know x is equal to r sine theta cos phi. Yeah. What is y? Y is r sine theta sine phi, and your z is what? R cos theta, right? If you remember. So we will calculate for x. So let's try. So the expectation value of x means it's like psi x psi, right? Yeah. So it's if you write 0 to infinity, 0 to pi, 0 to 2 pi, 0 to infinity for r, 0 to pi for theta, and 0 to pi for phi. Okay, so 0 to infinity for x. So x we will write r sine theta cos phi, yeah, into this becomes pi a naught q. Okay, 1 by pi a naught q, right? Because it is squared, right? It becomes squared because like psi, so psi star into psi, so it becomes squared. E to the power minus 2r by a naught again. Why 2r? Because again it is squared now. Psi will be squared. So this root over goes out and this becomes minus 2r by a naught. Okay. And your usual theta phi terms, that is r square sine theta d theta and d phi. Right? D, okay, dr is also there, d phi. So if we do it now, 1 by pi a naught q goes out. Okay. So integration. Okay. This r square. Okay. Sine theta d theta will give me. Okay. This sine theta d phi will give me 4 pi, right? So let's directly write it 4 pi. Into other, just we will do the dr now. Or sorry. Maybe a mistake. No, there is extra term now. There is this extra sine theta and cos phi term, so we have to do them. So let's do separately do them. So 0 to infinity. This is your r cube e to the power minus 2r by a naught dr, 0 to pi sine square theta d theta, 0 to 2 pi cos phi d phi. Yeah. So from here we can get pi a naught So the integration of this one is what? Can you tell me? Integration of this one is whatever the integration of this one. If you see integration of 0 to 2 pi cos phi d phi is what? Integration of cos phi is minus sin phi. Right? Minus sin phi is 0 to 2 pi. Sin 2 pi is 0, 0, 0. So the expectation value of x coordinate is 0. I hope you got it. You don't need to worry about these integrations now. This time. Just have to do the last one. If you do it, you'll get 0. Okay, one more question. Last question, question number 11. Particle of mass m moves in a potential Vxyz is equal to V1xy plus V2z. Okay, where V1xy is equal to half m omega square x square plus y square, and V2z is equal to 0 plus infinity. This is 0 less than z, it's an a, and infinity elsewhere. Okay, so let's now turn off V2z. Okay, so the degeneracy of the energy level, degeneracy of the energy level with energy 4 h cut omega is, okay, option A is 2, option B is 3, option C is 4, option D is 10. So please try. So see, here there are two wave functions, two potentials. So first potential, if you see, this is for a harmonic oscillator, right? This is for harmonic oscillator, we know. Yeah, and there are two coordinates x and y. And z coordinate, if you see, this is your this is a potential. Okay, right? This is a particle in a box, like potential kind of thing. Okay, 1D potential. So for harmonic oscillator, we know the energy, right? X y, suppose we know nx plus ny plus half plus half plus 1 h cut omega. And for the z part, this is a potential. So n square pi square h cut square by 2 ma square. Okay, right? So the thing is, now we have turned off V2Z. So V2Z is turned off. That means it's not working. So we will not take this into consideration. We will only take the harmonic oscillator. So 2D harmonic oscillator. So regeneration of the energy level 4 h cut omega. So how many times we will get 4 h cut omega? Let's see. So 1 is already there. So if I put n is n is 2, ny is 1 plus 1 h cut omega plus 1 is already there na? So 4 h cut omega. This is one combination, or 1 2 is another combination, 3 0 is another combination, right? 0 3 is also another combination, correct? So we are getting 4 combinations, so the degeneracy is 4. Okay, so that will be it for this class. Okay, so we'll be discussing more questions regularly from quantum mechanics. So you uh, keep in touch and keep watching. Okay, okay, thank you very much.